The tutorial we're going to look at here is really, it's really more of a kind of catch up. This is section 1, chapter 1. This is for those of you that were out, in case you needed to rewatch the lesson, or for those of you that were here that just needed to see the notes again, kind of what we did in class today. I'm going to kind of run through this straightforward, and you can kind of take it as you go. You can pause this if you need to, but this is what we're going to talk about. Really today is about problem solving. I'm looking at mathematical models that describe real-life situations. In this case, you've got a rectangular corral. What the important part is, it's rectangular. It's a shape. I'll also tell you that it's 3,500 square meters. That means we're looking at an area. The length of this object is 75 meters. I want to know its width. If you look at the next section, I'm giving you a couple of tips here to, okay, when you think about this, when you really look at it, and you really want to try to write out the formulas to make this as easy as possible, here's what you should think about. Well, which formula applies? Well, we know some basic formulas: area, circumference, things like this. In this case, I've kind of told you that I'm dealing with area. It's a shape, it's a rectangle, so that's going to be length times width. What else do we know? Well, we need to know what's missing. In this case, the width. If you were to draw a picture, and this is by far the most important part of word problems, always, always, always draw a picture. In this case, it would be simple. I would draw a box, and I would label the length 75, and I would label inside that rectangle 3,500 meters squared, and I would put an X for the width, or maybe a W for the width. In this case, it's easy because we know that the formula is length times width equals my area. And so you have 75x equals, or 75w equals 3,500. If I divide on both sides by 75, I get 3,500 divided by 75, which ends up being 46.7, which is exactly the width of that rectangular corral. This one is looking for patterns within numbers, and I've kind of given you a little bit of an idea that this is a linear pattern. The way we know that is that once I look at, if you look at the x-coordinates, you've got 0, 0, you've got 1, 6, 2, 12, and 3, 18. Those are the coordinates. I need to look at each one. If they're both growing by the same value each time, then it's linear. For example, if I can say 3 minus 2 is 1. 2 minus 1 is 1. 1 minus 0, that's 1. So the distance or the difference between all of the x-coordinates is 1. If I look at the y-coordinates, 18 minus 12, that's 6. 12 minus 6, that's 6. 6 minus 0, 6. Every time you do this, if you get the same number for both of them, they don't have to be 1 and 1, but it has to be, when you do the subtraction, they're growing the same way each time. X's are growing by adding 1s, Y's are growing by adding 6s. Now, another thing that's important is I wanted you in class today to describe this pattern in words and then find the equation that represents this. So I needed something in a sentence, and I needed something that says, here's the equation, y equals whatever. Now, one of the things I gave as a clue was the slope formula. If you don't remember the slope formula, it's y2 minus y1 divided by, all of that divided by x2 minus x1. That equals m. All right. Another thing that we talked about in class was, well, how do you find the y-intercept? And somebody chimed up very quickly that, oh, look for the x of 0, and whatever that y value is that matches is your y-intercept. So in this case, my b, or my y-intercept here, is also 0. So we get the final equation of just y equals 6x. If you look up the bullet before that, the words would be, if we multiply x by 6, that's how we get our y values. Or you could say, if I take each of the x's and I multiply each one by 6, then I get the y values. However you wanted to verbalize that, I need you to begin to verbalize what you see on the page. Let's go on to the next one. In this example, I describe a situation, and I wanted you to draw a picture. And this was a little bit more difficult. I'll do my best to describe it to you. Here's the situation. you are designing a new concert venue. This venue is square, so the concert stage is going to be a square that has a length of 54. So if you were to draw a square and then label each side 54 feet. The next part is, in order to create the walkway, which is going to go around the stage. So you have the stage, and then around the outside of the stage we have another kind of like a sidewalk that goes around it. It's also square. Okay, instead of 54, it's going to have to be longer to make it all the way around it. So now you have a square outside that other square, which this side length is 62 and 62, 62 and 62. So at this point, if you were to draw your picture, you should have a square on the inside with a side length of 54. You also have a side length, another square, a bigger square, that has a side length of 62. All right? The question is, I need you to tell me how far is it from the inside to the outside. So in other words, what's the width of your little walkway that goes around it? Okay. In order to do this, you have to you need to do things. First of all, draw a picture. Second thing, label what you know and what you don't know. If you look at the picture, you know that the entire length from top to bottom is 62 feet. Well, part of that 62 feet is the 54 feet inside on the stage. And you got a space at the top and a space at the bottom. Let's call those spaces X, because that's what I'm really looking for. That's how wide my walkway is. Well, if I know that the whole thing is 62, then I should be able to add those pieces together to get my total distance. So we got the three parts. So we have X plus 54 plus X, and that should be equal to 62. Right? So if I add those together, combine like terms, you get these parts. 54 plus 2W equals 62, and then 2W equals 8 after you subtract. Divide that by 2, and you find out your walkway would be 4 units long, or 4 feet long. And if you were to add 4 plus 54 plus 4 at the top, that should give you 62. I know it's kind of difficult to think about, but if you'll draw the picture and label it, and listen to this again, it might make a little bit more sense. If you still have questions, please ask in class sometime so I can clarify it. If you just take it a step at a time, do each part, it'll make the math a lot easier to grab a hold of. 2 more examples, and these may be a little bit more difficult to do on video. This one, the highest speed by a windsurfer is about 54.04 miles per hour. Now what we have is, we want to know how far he would travel if he traveled for an hour and a half at that top speed. One thing you have to remember is that we need a formula. That formula is distance equals rate times time, or D equals RT. Write that down. D equals RT. And this is pretty straightforward. If I'm traveling at 54.04 miles per hour for an hour and a half, I want to know the distance. So we multiply the rate times the time, and that gives me my solution. I'll put the solutions up on the side in just a second. I believe that was 81.06 is the total distance. The next part is, you and a friend are going to take a road trip. The total distance is 530 miles. Your friend drives for 4.5 hours at an average speed of 60 miles an hour. The question is, how fast do you need to drive in order for you to finish the trip in 4 hours? So, let me put up the solutions. Here's the solution to the first one. The second one, there's something I need to know first. I need to know how far to go. So we're going to calculate how far my friend went. So I multiply the hours times how fast he was driving. It's 270 miles. He drove just over halfway. Subtract that from the total distance to find out how much distance you have to go. And now I need to know, that's my distance. I know my time. I want to know the rate. Plug those into your formula and solve for R. Gives you 65 miles per hour. Take a minute, read the question, try to do it yourself, and then go back and check the solutions on the side. And that concludes the total of this particular lesson. The homework assignment was 1 through 7 all, and make sure that if you haven't checked the videos out for substitution elimination, make sure that you check those out. You have until next week to watch them, but they're going to give you a good idea of all the algebra that's involved. If you've seen those a couple of times before Monday, before we start going through some of this stuff, then it's going to make those lessons very simple, very quick. You'll be prepared and ready to hear those lessons.